Today, we're examining the emergence of a new market, one forming at the precise intersection of global regulation, national energy strategy, and powerful economics. We're talking about green methanol. In this analysis, we will break down the three fundamental forces that are converging to create what looks to be a pivotal new asset class in the global energy transition.
So let's get straight to the point. Our analysis shows that the rise of green methanol is not speculative. It appears to be the direct result of three powerful reinforcing drivers locking into place, which together are creating a unique, structural, long-term market opportunity.
So what are these three drivers? First, you have inelastic demand being created by legally binding global regulations. Second, there's a strategic imperative, particularly from China, to build out a massive supply base to solve its own domestic energy challenges. And third, there is a clear and quantifiable path for this fuel to become economically viable, even cheaper than its fossil fuel counterpart. We'll break down each one, starting with the demand side.
Okay, let's begin with demand. The entire foundation of this market rests on what is essentially a compulsory, irreversible global mandate to decarbonize the shipping industry. This isn't a voluntary pledge, it's a set of rules that's creating a guaranteed customer base from scratch.
The International Maritime Organization, the IMO, has set an aggressive and, critically, legally binding schedule. The key deadline to watch is 2030. That's when up to 10% of the industry's energy must come from zero or near zero emission fuels. Now, for an industry where ships have a lifespan of over 20 years, that 2030 deadline means investment decisions have to be made now.
And here is the crucial point that turns this from vision to reality. These aren't just aspirational goals. They are enforced through amendments to the MARPOL Convention, which is a binding international treaty. This mechanism is what gives the IMO's targets real legal teeth, transforming a climate objective into hard, enforceable law for global shipping.
And the enforcement works through a very powerful dual lock system. First, the country where a ship is registered, the flag state, is required to enforce the rules. But the second part is arguably more potent: port state control. This means any member port, anywhere in the world, has the authority to inspect and even detain a non-compliant ship from another country. For an industry built on global trade, this makes evasion practically impossible. On top of this global framework, you have regional policies hitting the accelerator. The European Union's emissions trading system, which now includes shipping, and its upcoming Fuel EU Maritime Initiative are already creating early demand hotspots and real price signals. This is happening years before the full weight of the global IMO measures kicks in.
So what does this all mean in terms of market size? That 2030 mandate is creating a massive market out of thin air. As you can see, our baseline forecast projects demand at over 14 million tons by 2030. To put that in perspective, we're talking about a multi-billion-dollar market materializing from virtually zero today.
Okay, so with that guaranteed demand locked in, the next logical question is, where is all this green methanol going to come from? The answer, it appears, is largely China, which has its own powerful domestic reasons for wanting to become the dominant producer.
You see, for China, green methanol is a solution to a huge domestic energy challenge. The country is building out wind and solar capacity so rapidly that its grid can't always absorb all the power, leading to what's known as curtailment, essentially wasted energy. The national strategy is to take that excess, often very low-cost renewable electricity and convert it into a stable, transportable liquid fuel, methanol. This isn't just an export play. It's fundamental to China's own energy management and security.
And a very recent policy shift has just opened the floodgates for this strategy. China has pivoted from a dual control system capping total energy consumption to one that caps carbon emissions. Now, the crucial detail here is that using renewable power to produce something like green methanol no longer counts against provincial energy use targets. This single change has effectively removed the primary administrative hurdle for these projects, signaling a massive strategic green light for investment.
So we have a clear picture of the demand drivers and the supply side strategy. But how are the end users, the world's biggest shipping companies, actually positioning themselves for this shift? Let's take a look at their divergent strategies. If we look at the two largest global carriers, we see two very different approaches. Maersk has adopted a pioneering all-in strategy on methanol. They've placed aggressive orders for new methanol-powered vessels and are actively working to build out a global supply network. In stark contrast, MSC, the world's largest carrier by capacity, is pursuing a more cautious, multi-fuel hedging strategy. They're focusing more on LNG and ammonia-ready ships, essentially taking a wait-and-see approach on methanol for now.
And looking across the top 5 carriers, we see this fascinating strategic split. Now pay close attention to COSCO. Like Maersk, it's investing heavily in methanol ships, but its approach is unique. It's pursuing a national team strategy, vertically integrating its shipping operations with Chinese fuel producers and ports. This creates a kind of self-contained domestic ecosystem for green methanol.
This brings us to the final and arguably most important pillar of our analysis, the economics. Can green methanol actually be produced at a cost that makes sense?
Ultimately, for any investor or stakeholder, it all comes down to this single question. Can green methanol ever truly compete on price with conventional fossil fuels?
The path to cost competitiveness is actually quite clear and simple. It's almost entirely dependent on a single input, the price of green electricity. Because renewable power represents over 80% of the total production cost, the established long-term downward price trend for wind and solar power is the price trend for green methanol. The two are directly linked.
Our model indicates a critical economic inflection point at a green electricity price of just 0.1 RMB per kilowatt hour, a price that, by the way, is already being seen in curtailment scenarios in parts of China. The production cost of green methanol could fall to around 16-18 RMB per ton. Now that number is significant because it is below the historical market price for fossil-based methanol, signaling a clear path to profitability, potentially without the need for long-term subsidies.
We see the window between 2025 and 2027 as the critical inflection point for the market itself. This is when several things happen at once. The first large-scale production plants are scheduled to come online, just as binding EU regulations and an expected global carbon pricing mechanism from the IMO kick in. This is the moment when, for the first time, large-scale supply will meet mandatory price-driven demand.
Finally, let's zoom out to the long-term strategic picture. The value proposition for green methanol extends far beyond just being a shipping fuel. Because it's a stable liquid at room temperature, it is one of the safest, most efficient, and most practical ways to transport green hydrogen over long distances. So, in effect, the infrastructure being built today for the maritime market is also building the logistical foundation for the broader hydrogen economy of tomorrow. And this leads us to the final analytical question. Is the investment case for green methanol really about a transition in marine fuel, or are we in fact witnessing the foundational build-out of the infrastructure for the future hydrogen economy? The answer to that question will likely define a significant portion of the energy transition landscape for decades to come.